Hi, I'm Keith Norbie. I'm with SolidFire. I'm in the Office of CTO with Val Berkovici. And today we're talking about software-defined storage. Now, this is certainly not a new topic, but I want to try to shed maybe my own angle on this and defy what I think are some misconceptions about software-defined storage. In this case, just if you look at the data centers that have been at play with most large enterprise and service providers, what SolidFire and what software-defined data center and software-defined storage have really been aimed at have really been about next-generation data center. And if you see to the left side is sort of the last-generation data center's attributes, where you have a lot of single tenancy, isolated workloads, silos, very scaled up in resources, very harder to find and very project-based. Versus the next-generation data center really demands something of storage that you haven't done in the past. And you'll see things like shared infrastructure, mixed workload, multi-tenancy, capacity on demand. It's the consumption and the agility of the platform that really creates a new demand that takes us beyond just installing software on any old hardware. So let's take a step back and just talk about the history of SDDC and software-defined. And while there certainly are people well before 2012 that may have given us definitions about software-defined, it was really this time and year when Steve Herod brought the software-defined data center term to network interop and really created the first vision for VMware to really mass commercialize the concept of being software-defined, which is really the abstraction, pooling, and programming resources for utilization for VM and app builders in an infrastructure. So I've had some fun with this. If anything, let's be a little creative, and we'll take the ACDC logo and create a little SDDC Rocks t-shirt and throw some bunny ears on with Amy Lewis, and that's usually a pretty good recipe to have some fun. So just to review real quick, the thing that we've been fighting against from the classic perspective is very harder to find storage infrastructures. You see this in the traditions where you've got the monolithic storage or any kind of traditional package that has a dependency to being installed on a piece of hardware. And this could be Intel-based, this could be non-Intel-based, but you know what you've seen in the past when you've seen the monolithic hardware-based storage. Now the software-defined approach is one where you apply a software code base onto typically x86 or Intel, but it doesn't necessarily have to be that. And I think what everyone tries to figure out is how do I make everything more agile is the key. And so that doesn't mean that software-defined necessarily always says it has to just be software installable on any old x86 hardware. I think the actual definition of software-defined storage kind of reaches a different height than what traditionally has been put together. And really when you think about that, traditional storage has been a lot about VMs and a lot about trying to create relevancy to special functions and things around software-defined for virtual machines. But what if I've got OpenStack? Does that also mean that goes to an open source version of a hypervisor versus just being VMware? Because VMware doesn't own the whole term software-defined. That's a kind of a pliable definition that goes across architectures. Also, what about PaaS? Programmers require infrastructure because program developers and application frameworks that use PaaS doesn't run on nothing. So it has to have some kind of a resource provided from a cloud infrastructure or a service provider or your own private software-defined data center. So what about PaaS? And then also, the latest craze, which is containers and developer-driven ecosystems, also known as Docker and some other things. So in this realm, the Docker and the persistent storage craze has really come of age recently. In the first phase of Docker and containers, everyone thought that storage does not need to be persistent. And as you get more and more adoption of this, you found the need for both persistent and non-persistent storage. And so the premise of storage and software-defined storage in a container ecosystem really gets driven from a single Linux server construct. And many containers can be driven off of that single Linux host across multiple hosts over time. And it's driven by a consumer that wants a specific level of agility, a programmer, an operations guy to help supply the programmer, and give a business driver towards not just agility, but continuous development, continuous integration, and ultimately an evolving ecosystem. And these are a lot of the names that we've seen previously, like Docker. You've seen Red Hat with Ansible, you've seen Rancher, and Kubernetes and Mesosphere and the likes. The key here is as you go from a base Linux operating system and provide bare metal resources, in this case, software-defined resources, the key is about trying to get a plugin and making the storage definable for containers that could live for seconds, hours, weeks, or forever. But the plugin is something that really has to expose what you do from a storage perspective up natively to Docker and the orchestration of Docker. And it's when you expose this to the ecosystem of clustering and orchestration and paths that you really start to see where there's separation and there's a lot of things to investigate relative to software-defined storage and a Docker container ecosystem. So as you look through that and you think about how you do software-defined in a container ecosystem, this is how you might want to think about it. So I think where you start with trying to figure out what software-defined really is, I think you think through criteria. So I put together this criteria thinking through first performance. And I think, in the past you've seen software-defined take storage and do pools and tiers of storage and have to do some hard math and continue to do hard math and hard tools to help give you an understanding not just for performance, but for capacity and also performance. So I think in SDS, the first thing you want to reach for is how do you split performance definition from capacity definition. I think the next is you got to be able to have the ability to take and have dials that move those capacity and performance attributes up and down relative to what you need for resources. Also, you want to have the ability from a software-defined perspective to understand how you can scale. And once you scale, what is the ability for you to expose the capabilities of scale non-disruptively in ways that you can scale up and scale out and also back down. You also want to look for data services in a software-defined nature. There are some that are foundational, like efficiencies, that in a lot of architectures will be always on, but there's some that might be selectable, like data protection elements like snapshots and replication, encryption and other things. But it is the capabilities and how you can turn on or selectively utilize these through a software-defined platform that becomes the point of being software-defined, as well as APIs. So kind of the fifth part in my mind of criteria for software-defined storage is having a set of APIs that you can program to. So not just taking resident things like performance controls, encryption, snapshot protection, et cetera, but also being able to take and do some API programming against that software-defined storage layer. Because when we come down to it, it is about trying to not just take the capabilities of a storage system and make it software definable, but also trying to figure out how we can deal with the tasks of the past. And if you look here, we've got a pretty complete set of things from design to upgrade and the full life cycle of storage management. And there's a lot of stuff here that people have had to deal with, and maybe it's no reason why some people hate storage. And I think what we try to get to is how can we slim the pair of instructions and tasks down through focusing on what software-defined platforms should deliver in their capabilities, and in trying to focus on ease of use with the software-defined platform. You can really focus down things that in the past were sort of trapped with harder-defined platforms. Software-defined platforms that have a lot of capabilities, and in this case, SolidFire has a way to sort of simplify down the deck of things that traditional admins have had to deal with, and really leverage what software-defined I think was really supposed to become. So where does SDS matter? And I think SDS has different levels of impact for how they matter. We've seen this done. If you've ever seen Dave Wright's consumption continuum, it kind of rationalized a lot of different ways to look at how different storage platforms fit from the SMB consumer all the way up to hyperscale. In this case, I use an inverse triangle to say numbers of workloads and agility demands are sort of the things that increase exponentially as you go from an SMB up through a hyperscaler. And so SDS matters differently. In the SMB, I would argue that in a really small area, you shouldn't be looking for a software-defined storage platform. You should probably be looking for a service provider. That's a better way to leverage at scale the efficiencies of what software-defined storage has become, as made apparent for SMB through cloud consumption and service provider consumption. Commercial, that's where we're looking at typically the single array. You see HCI and hyperconverged kind of dominating in this area because people don't have storage skills, and so they want to apply software-defined characteristics through a very easy-to-use platform. It doesn't have to be hyperconverged, but these are single platform arrays in the commercial end. In the enterprise, You see much more large-scale, multi-cluster or multi-platform type of infrastructures for different reasons and different demands, as well as different generations of technologies they live through. So when you software define for an enterprise, different than a commercial or an SMB, you really start to see the first level of impact at scale for operations and things that capabilities in a software-defined platform, I think, really show. And of course, hyperscale, this is absolutely where it shows and where the demands of software-defined are the most incredible. This is where people buy in shards or multi-rack configurations at a time, very high levels of standardization, very rigorous operations, high levels of automation, and so defining storage in a software-defined storage model, the task here is much more for at-scale environments. And so you have a wide range of things where I think SDS matters here, is depending upon the size of your accounts. I'll conclude with this. In my opinion, this is where it matters. Software-defined is not necessarily just, can I load my operating system for this storage system on an x86 box? That, in my mind, does not fully define what software-defined storage is supposed to be about. I think if Steve Herod was talking about the software-defined data center, he wasn't just talking about loading software onto Intel hardware. I think he's reaching for programmability. He's reaching for functions and ways that he could call up, ways to pool, abstract, and automate resources that mattered. And in this case, what are the resources? What are we trying to do? We're trying to take media, raw hardware media for storage. We're trying to take architectural types and understand how in each architectural type we could make them software-defined. We're looking at capabilities that are not just capacity-based, where we're trying to define a capacity and then calculating the hardware performance separately, but not having a software control for that. I think that, along with things like encryption and different availability zones, all start to become part of a software-defined platform. And then, looking upscale, looking at how application workloads, both traditional, big data, microservices through containers, what does software-defined capabilities matter for each of those types of workloads? Like QoS, as an example, matters in mixing these workloads together to give you some programmability and containing workloads that might interfere with others. And then consumption, which has really become the key and the king of our industry, which is how can I take these capabilities and make these very agile in how people want to consume them. Docker has given us this lesson probably most recently, in the sense that people want to demand in a DevOps fashion, where they don't want to have to deal with traditional IT resource infrastructure people. They want to demand on the fly, at their time, and at their pace. And in this case, agility is certainly one factor. The other is, how do I reduce the cost of a platform over time? And then the one that's not often mentioned is flexibility. And that's a very big attribute of software-defined storage, is trying to figure out, this isn't just the flexibility of me installing my storage operating code on one piece of hardware or the other. It's what can I do with it? What's the flexibility of the functions and how they work across different parts of the software-defined data center. In my mind, it's basically like the Logitech Harmony remote that some of you might have seen, or TVs that come with a lot of apps in one single remote. You press a button like Watch TV, and it works with all the rest of your home audio functions and automates the capabilities of each of those component functions in a way that lets you simplify and have a great ease of use experience, as well as the agility of not having to shuffle multiple remotes. That's probably the best parallel analogy I can give you to how software-defined storage should work. And that's my talk. Thanks, and my name again is Keith Norbie.